Yeah, I'm going to do a quick Q&A session right now, okay? Just to get a sense of what you guys do. How many are on Azure? Just one person? Really? 3. All right. How many on GCP? Google? All right. AWS? Damn, that's impressive. And Snowflake? One person. Databricks? Hi, Tony. How's it going, man? Databricks just one. I think I've seen you before in one of my talks. Yep. You're hiding with a baseball cap over there. Something about myself. I'm a principal data scientist. I work at Capital Power. I have 2 portfolios. Asset optimization. So we have wind turbines. We have, what else do we have? Power plants. We have, what else do we have? Solar plants. And then that's one of the parts of the portfolios. The second portfolio is what we call trading algorithms, so commodity trading. So think about natural gas, think about oil, think about power, all of that stuff. However, I have to caveat by saying, anything that you're going to see here does not necessarily mean that it's a Capital Power solution. I'm not here as a Capital Power employee to market my product over here. The second thing that I do is I teach at Queen's University for executive program called MLOps. And essentially the role is a lot of C-level folks, just like yourself. I'm guessing any C-level folks here? Director, VP, CIOs? Come on, guys. All right. Well, there's one. I think you're just faking it. All right. So essentially what they do is they want to understand what MLOps is. They have big budgets. They're trying to figure out what to do next. What are all these fancy roles? So without that, by the way, this thing is going to go 10 minutes over everything. Everybody okay with that? Yeah? Show of hands, yes, no, yes. All right, cool, thank you. So, I'm going to give you the value proposition for today's agenda. It's going to be one of them. Then a brief introduction of what the hell MLOps is. And then probably put meat to the bone, hype it up for you guys a little bit, and show you what a real-world solution in MLOps looks like. I'm not saying you're going to get a taste of Google level, but it should be good enough, I think. So, I guess you guys can read the bullets, but I go off script quite a bit. I'll tell you 2 scenarios here. One scenario is that you're a data manager and you hire a data scientist. You have some budget for an FTE, one full-time employee. The person comes in and develops something. 6 months, 3 months, 1 year. FTE does an R&D activity or data science activity. And then what happens is they build the product, but only a semi-product. It's not production ready, meaning that it can't go to market yet because this person built a Jupyter notebook in a siloed environment. So the next question comes is, okay, there's a P&L number here, right? Profit and loss. Maybe from an optimization standpoint, it saves you money. Then the next step comes in and it's, hey, data scientist, take it to market. Well, here's the scenario 1 problem of why MLOps is important. Where is that person going to go when they want to productionize it? Any guesses? Which department are they going to go to? DevOps? Close. Anybody else? Actually, I'll give you a point on that. That's actually the right answer. ITIS, right? Why? Because ITIS are the only business groups that know how to build production-ready systems. It's pretty straightforward. Now, what if, and these are real-world scenarios, now what if this data scientist wrote a bunch of R code? How many people in ITIS know how to read R code? 0, right? So how are you going to, you spent, just to kind of give you the whole story now, this person spent 12 months, R&D, FTE, coming out of your budget. The thing works, but you can't productionize it because this person did it in R code, right? Now, some R enthusiasts here, I'm sure Julia enthusiasts too, but I'm just giving you context here. So now what you have to do is, this beautiful product is going to sit on the table until people figure out how to refactor this code or take it to market. That's scenario 1. Scenario 2, let's say they figure it out. You figure it out. And you say, oh, we have an ITIS person, there's one person that knows how to read our code, we're going to productionize it. Productionize it, you get a P&L, You get a P&L of $500,000. 6 months go by. Your data scientist leaves. What do you do now? You're stuck with a model that only one person understands, and there's no code repository. You productionized it, the thing is starting to drift. That, ladies and gentlemen, is the value prop of MLOps. So now let's ask, which of the following are you measuring? Choice of hyperscaler. Where does this data sit? How is the model deployed? Is it none of the above? And juxtaposition, all of the above. It's a contradiction. I'm not going to show that one. So I'm going to put some meat to the bone before we get to it. This is what you're looking at is a simple anomaly detection model. Okay? Very simple. It's simple, concise, and delivers the message. Anybody sitting in this room can figure out what this chart means. This is an anomaly detective dashboard. Simple. What this is doing, in reality, is the back end is very sophisticated. I'll walk you guys through, but this is the key message. Anybody should be able to understand. The business stakeholders should not, and they should not, care about what the back-end system looks like. This is a trading algorithm. Every 15 minutes, back-end churns up. It tells the trader what to do. Every 15 minutes, buy, sell, take profits, buy, sell, take profits, buy, sell, take profits. Again, pretty simple, right? I mean, you can kind of figure out in 2 to 5 minutes how to use this dashboard. Backend, nobody knows. And guess what? The business doesn't care. That's the sad reality. But the message is delivered. A C-level, a trader can use this dashboard and get boots on the ground and start using it, even if the traders switch. This is the backend. So there's 1,000 pieces of equipment. I can't say what kind of equipment. There's about 200 sensors. Every 60 seconds, 12 million rows of data per minute connected. In 30 days, you'll have about 518.4 billion rows of data. In 12 months, you're going to have 6.2 trillion. The back end is this. 496 cores running on Spark, 4 terabytes of RAM. In the cores world, that's 100 times the magnitude of your common computer right now that you can buy off the market at Best Buy with 8 cores. That thing is 100 times more powerful. The memory that it has is also 100 times more powerful. Does the business care about this? No. But here's where the real value is coming from. The number one thing that people get wrong, and we should do it right, is this what happens in a legacy environment. A steering committee is created before data science is kind of joined. They come up with use cases, and then they say, hire a data scientist to fix this use case, address this use case. That's kind of how it works usually. Wrong. And I'll tell you why. You should get a SME, a subject matter expert, and a data scientist in a room, and a data engineer, the unsung core hero of the data world. Go look at the data first, because you will have steering committees who have no idea if you even have the data to use that, and you'll come up after 3 to 6 months, and then you'll put a data scientist in front, and you'll realize that that doesn't happen. So the real context, or the real story really is, go for the data, understand it, and then come up with the use cases. And the use cases have 2 context subcategories. 1, high value impact, high risk. Meaning, this is a home run. It's not a low-hanging fruit, but it's going to be a big win if somebody solves it. Second is low-hanging fruit, but low return. And that preferably is mine, and I'll tell you why. Because a low-hanging fruit that you know that you can solve is going to engage the business, and they're going to become believers because you'll be able to solve it. There's a high probability you will solve that low-hanging fruit, and that relationship is going to be paramount for the success of all future use cases. If you go for a home run, a for an R&D activity that is 10x value, good for you, but if it fails, you have to rebuild that relationship. All right, maturity curve assessment. You guys can't see it, but essentially, I teach this course. I'm giving you a condensed form of the C-level course, but there's 4 levels of maturity before you kind of figure out where you sit in the pedestal. So the stuff that I'm going to show you today is the highest maturity level solution. You don't have to be there, but here's the 4 ones. Level 0. It means that you don't have a robust data platform. Oh yeah, that is just great. All right, level 0. You have no cloud architecture, and you rely mostly on on-prem data. Does everybody know what on-prem means? Who doesn't know what on-prem is?
On-premise.
On-prem is like your servers, your data centers that an organization basically handles. OLTP systems, transactional systems, like think about when you make a transaction on a POC device, point of sale device, that thing goes into a transactional system. You should never, ever build your analytical workloads off that. Anybody want to take a wild guess why? Close?
The speed isn't there.
Good? There you go. There you go. If you start building an ML workload off an OLTP system, your transactional system, where all your transactions are being logged, you're going to crash it. So never build it off that. You have a citizen data scientist willing to test new things. You may or may not have a data engineer or software engineer, so you're a very small team. That's level 0. Okay? Means that your data maturity, your architecture and maturity is pretty low. Level 1. You have some cloud architecture. You have on-prem. You have software engineers. You have DevOps. You have small to mid-sized teams. You have software engineers. You have DevOps teams. You have small to mid-sized teams. So think about like an SMB with a data budget. Small business. You do software. You do apps. And you do it for internal and external services. Key thing between the difference between level 0 and level 1 is that level 1, you are moving towards data as your world. Level 2, you have lots of cloud architecture and on-prem. You have everything that level 0 and 1 have. But data is your world, and you need to start building a data science team or upskill in-house. So 0, 1, 2, final. The most mature one. You have lots of cloud architecture. You have everything from 0, 1, 2, 3. Sorry, 0, 1, 2. Data is your world, and maybe, just maybe, that is also your main product. You're building data science models in production, and my talking points is gone now.
Don't worry.
And you probably have a big budget. Oh, there you go. Look at that. Thank you. Oh, you guys love my slide deck. Look at that. I put some work into this. Scale of 1 to 10, how much do you guys rate this slide deck? Now that you can see it. Did somebody say 2? Sorry? Oh, appreciate you. Thank you. Okay, so level 0, one more time. Do I need to go through this or do you guys catch that? Good? Okay. Okay, the level 3, you probably have a big budget. Now the solution that I'm going to show you guys today is level 3. You don't have to be there, okay? I'm just showing you the most sophisticated system you can build. So before we do that, we're going to do a big, small crash course. How many of you guys know 5 V's of big data? Man, come on. All right, good, I like that. Volume, velocity, variety, value. Got it. So when you're building MLOps, you have to actually just focus on 3 to build your value prop. The volume of data creates a lot of chaos in MLOps. The velocity of data, the speed at which it's coming. And the third one is value. We'll get to that. Is CSVs bad in production? Bad in production? Probably. Because it can get corrupted pretty easily, but that doesn't mean that you have to do it. Is Python good enough? Yeah, it is. But it also depends, because the stuff that I showed you cannot be done in Python. Does anybody want to guess why? Yep.
The global interpreter lock.
Okay, that's the nerd guy. Okay. Essentially, it is if you have 496 cores, you can only use one thread out of that. Okay? So it's severely limited. No matter how much distributed computing you have, Python will not do that for you. What is big versus small volume? So I showed you what big is, but in your context, that probably isn't big. It's probably too big. Now, the part that everybody's familiar with is historical data, right? It's pretty straightforward. Historical data, give me a CSV file or a Parquet file and build a model around it. Pretty straightforward. The incremental is the one where MLOps is needed, and that's where the people fail the most. It's because what happens is, when the data scientist wants to start building a model, the person who is looking for the data gets a one-time data dump. And when you want to go to market, that inference, the prediction, right, that needs incremental data to flow in to some system, that doesn't exist yet. It's not there. And that's because the data scientists built something, but they're not software engineers or data engineers. They don't know any of the stuff. They just think that if they plug and play, the data will just be flowing into a pipeline and the predict function will just run. The incremental is the hard part. Velocity, the need for speed. That bunny, by the way, generated artificially. It's not a real bunny.
Mid-journey?
Yeah, you got it. So again, I talked about transactional versus analytical, granularity, how deep you want to go. If you're doing monthly, so if you go back to the two use cases that I showed you, the very first one, for the equipment, that thing was batch. It runs once a week, but there's a lot of data behind it. That would fall under your monthly loads, or weekly loads, or whatever, they're batch. The second one, the trading one that I showed you, that's near real time. It's running in every 15 minutes. Completely two different systems. And a completely different architecture because the needs for the business are totally different. That's the critical point here. Variety. I think everybody understands this. Audio, Parquet, CSV. How many of you guys know what Parquet files are? Yes. Gallery is on point. All right. Value. What is the ROI of all this data architecture? Is it BI or AI? That's one of the things that people confuse. Reporting, BI. Prognostic, prescriptive, AI. How many of you guys have seen this? Okay. High level, data warehouse, asset compliant, meaning that if you try to corrupt that data, it's pretty hard to do. SQL servers. Data lake, unstructured, Azure Blob Storage or S3 buckets on AWS. This is where data scientists have been working the last 10 to 15 years, 10 years actually. Lakehouse is basically a combination of both data warehouse and data lake. So it basically gives you all throughput and capacity and allows you to scale up while being something called asset compliant. I'm not going to get into that nerd talk. So this is what a sample ETL looks like. Extract, transform, and load. There's another one that's around now. It's called ELT, which is the new version. Extract, load, and transform. Snowflake, Databricks, these guys allow you to do that stuff. The key point here is that you see the bronze layer? That's the raw layer. So when I was talking about the on-prem stuff, you move that transactional data onto the cloud, right? You put it there, and that becomes your bronze, meaning that that's your single source of truth for any analytical workloads. Without getting too technical, don't give your data scientists write privileges to that thing, because they will write to it and corrupt that data. So that is read-only. Silver is where you build a curated list, meaning that high level, you take the data from the bronze, you do some transforms on it, store it on the bronze layer, and you give it to data engineers. I'm going to talk about something called feature stores. Keep it in mind. That thing sits on the silver store. Gold, BI stuff, aggregations. Pretty straightforward. Everybody on point here so far? I'm concerned about people that are not raising their hands. All right, feature store. Again, I don't want to get too technical. This is the stuff that I'm talking about, even from the business standpoint, you should understand this. This is what I do in the course as well. And the reason because when data engineers, PMs, technical PMs talk to you guys, or if you guys are taking point, you need to understand the basics of what these tools really are. and what the value prop is, and if you really need it. Traditionally, in this example on the left, what you're seeing is, let's just say, forget the thing, let's just say that a data scientist builds a model, a year later, 6 months later, that model starts drifting, accuracy goes down. Now, what you do is, you have to ask the data scientist, say, hey, we're losing money, the model's not accurate, can you go back and retrain the model, or rebuild a new model? No matter how good the code base is, when they go back to 6 months to looking at this, all these model one, model, the iterations, and all these multiple single sources of truth, which is the data warehouse, database, real-time data, they don't remember anything. You're going to spend time, and a data scientist FTE is very expensive, right? So that person is going to be spending 2 to 3 weeks just trying to remember what the hell they did before. Even if the code base is really good. That's where feature store comes in. Because in the feature stored world, you merge all the sources of truth into a single place and allow the data scientist to experiment. It's very simple. And do you need it? Probably not, because you're not there yet. But in 5 years, when everybody will have data engineering best practices, data pipelines, etc., this will become a standard, because otherwise what's going to happen is data scientists are going to start writing back, and they're going to corrupt the data and crash the servers. People are going to have to learn this part. It's a pretty looking chart, but that's all it is. It's not that hard. The only part that's hard here is the offline store is where you store all the stuff. Okay, that's all that matters. The online store is the hard part. And the online store is basically where, when you're running real-time prediction models and stuff like that, this is where the problem will start. Because you have to manage, and your costs will quadruple very easily. But on the bad side of the feature stores, you can at least manage that somewhat. Here's a sample of, these are actual models that I've built. There's about 3,000 models in here right now. How much time does anybody have to go through 3,000 models in a model store? So what you do is, you basically build a deployment platform, and it's called Canary Pattern. It's from software engineering. Again, MLOps, if you look at the very first chart, it's a cross-sectionality of essentially taking software engineering best practices, stealing a little bit there, stealing a little bit from data science, stealing a little bit of data engineering, and putting it all together. This pattern is from software engineering. And all you're doing is, and you don't have to do this, there's other ones too. I think it's called blue, green, a bunch of other ones. What you do is, you take the model, and you say, well, guess what? I'm going to roll it out to a subset of users only and test it out, because I don't have time to do unit testing, meaning that I'm going to write a bunch of code to make sure that this thing is not doing what it's not supposed to do. And once it works out, you roll it out. And this is kind of like how the engine looks like. Okay. All it is you have, MLflow is open source, by the way. All you're doing is you build your models in 3,000, put it in a dump it in a place like this, and every week what happens is, if you know what you're doing, you hard code it, and you say, pick the best model, move it into a canary pattern, and run the inference. That's it. So what would take me weeks to do is fully automated. Congratulations, you deployed your model, you built the system, now you got to watch it. Do I have time to watch it? No, because I'm working on 5 different projects, right? This is the drift system, so when it starts going haywire, who is responsible for fixing it? Data engineer, DevOps engineer, ML engineer, stakeholder, business person who doesn't know how to code, right? Who will diagnose the source of the issue? It's drifting, you're losing money. If it's my trading platform right now, it's losing real money every 15 minutes. Guess who's pissed off? The trader. Why? Because the traders, the way they work is, as an example, their compensation is tied on bonus. Right? They don't care what's going on. They don't care why it's drifting or whatever. They just want this fixed. Because they make 100% of their salary in bonus. And if it's a hot day and the model started doing something crappy, you got to fix it, drop everything, and do it. That's why this stuff is important. If your equipment is failing, and it's that season where, I don't know, oil rigs are up and running, You got to fix it. Company's losing money. Downtime costs money. Essentially the point I'm trying to drive home here. Types of drifts. Okay. All noise. There's a paper written about it. The only one that I absolutely hate is when your drift starts happening. Okay, so take a step back. There are two types of drifts: concept drift, target drift. Doesn't matter. It's technical. All that matters is that when your model starts drifting, the accuracy starts going down. It's either in the data that you fed the model to train that is no longer representative of the real world data anymore, or it's because the very thing that you're trying to predict has fundamentally changed. So think about natural gas prices. Where were they in August when Ukraine war started, and where are they right now? They're record lows. Back in August, September, they were record highs. In 6 months, that paradigm has completely changed. That's a drift, because the market fundamentals is something that the model's not been trained on. The one that causes me nightmares is that last one. Because what happens is, the blue little thing is showing you, I'm laughing because this is just a terrible idea. But what happens is that when the model starts drifting, you implement a fix. And it started drifting in red, right? By the time you implement the fix, it's gone back to the old pattern. And you don't know when the hell that happened. So now you got to figure out, do I revert back to the old model or do I revert back to the new model? This happens a lot more, and there's no good way of doing it. All this matters. Why does this matter? Because you don't have to build and hard code it. There's free open source tools, it's called Evidently AI, that you can use that basically monitors your data that is going into the system. So I'm going to show you now a real life implementation after talking all that technical nerd jargon. Again, keep in mind that this is the most mature architecture. This is level 3. Okay? You don't have to have that. It's an expensive architecture, but this is kind of what I would say fan companies are kind of leveraging as well. So what you have is, you want to be dependent on any of those 3 major providers. On the left is Databricks, on the right is Snowflake. Use them both for where they belong. This is what the final architecture looks like. There's something called Atacama. How many of you guys have heard of a data catalog? Michael, you're a superstar. Of course you would know this stuff. Anybody else? Okay, I didn't talk about data catalog because I don't have time. The single best investment, if you're a legacy or enterprise grade, you can make is a data catalog, in my opinion. And the reason is because the amount of time it took me to chase data down in 3 to 4 months, chasing all the stakeholders down, trying to figure out where's the data catalog allows me to do it in a week. Because every single source of data that the company or organization has is in a data catalog. So it is literally a Google search. And I know exactly which data is where and how frequently it's being updated, if the transactional system exists, if the incremental is happening, the whole shebang. So even before I go and engage with anybody in a data catalog, I get the full perspective. I know exactly where the data is, and if I should even be leveraging it. So the way it works is I look at the data catalog, I find the data, I move it to a data warehouse, Snowflake. I use Databricks to pull the data out of the data warehouse in Snowflake, pull it out, train your model, and then push it back to a Snowflake data warehouse, and then just connect your visualization to it. That's it. So the Power BI is connected to Snowflake. Your entire data set is literally on Snowflake. Your entire ML, compute, Jupyter notebooks or notebook environments, experiments, everything, AI, ML related, is on Databricks. Everything that the AI, ML model does that pushes it out is in Snowflake. And the Power BI stuff, it just doesn't even talk to anything else. It just connects to the data warehouse. This is the power. All I'm showing is there's 453 million rows of data on Snowflake that I queried in 5 minutes. I cached it, again, nerd talk, 1 minute. 500 million rows of data. So that engineering that I showed you guys, this is what the back end is. Does the business care? No, but I'm hoping you guys care. It's pretty cool. And this is what it looks like. Snowflake data warehouse, pushes it out to a Databricks, spins up my experiments, keeps running, and pushes it back to Snowflake. Again, this chart. This is what the backend looks like. 352 cores, server load is 92%, meaning that it's really being used, and memory is hidden, but memory is right there, and there's about 2.0 terabytes of memory. Now comes the interesting part, dashboards. Probably the most important thing that you guys will do. There's a single underlying story that I'm going to give you guys at the end. You see this thing? It's level 1, meaning that executives use this level. Meaning that they don't care about the back end, they're just looking at the anomalies. So the very first model that I showed you guys, the anomaly detection, this is what they're looking at. And all they care about is count of anomalies that are happening in the entire asset base, basically all the equipment that we have. And they basically look at this, once a month, whatever, and delegate. Level 2, managers. Managers are looking at this to create action. So Jira board, ticket items, figure out what you should be actioning. Level 3, analysts, operators. They're all looking at this. There is over 10 billion rows of data in the back end over here, in this dashboard. Do they care? Same thing again, different view. That's pretty HTML. But you know what the pitch of that was? Let me go back. These 3 levels that I just showed you guys, they are one dashboard. They're not 3. And the reason why that is important is because when a C-level is talking to a manager, they're not referencing different data points. They're all looking at the same dashboard. So when they get into a room, they're not screen splitting to look at one dashboard and the other one and the other one. This is literally one dashboard. And the backend has over 10 billion rows of data of all the entire Azure, Databricks, Snowflake engines that I just showed you. This is what it comes down to. That's it. And then everybody gets into a room and gets the work done, and you hope to God that things don't break. That's my presentation, guys. Any questions?
Thank you very much for the great presentation. I have a very technical question.
Yeah, go for it.
When the model after it gets deployed, when its performance getting worse, can feature importance be used to identify the root cause of why it's getting worse, or can feature importance change if the model performance is getting worse? Thank you.
Yeah, that's a very good question. So basically, what he's asking is, instead of using this system, can you just look at the features and look at how they're performing and maybe identify the stuff that you gave it? Maybe one of those columns is causing the drift. Yes, you can do that, but if you're using neural nets, maybe not. So it's a little bit of catch-22. In one of the slide decks, you'll see that I had 3,000 models, and under the model column, I had the model column grayed out. And I said there's 3,000 models. They're a combination of XGBoost, which allows you to do feature reports that you're asking about, but neural nets, not so much. So it depends on which model you're looking at. Does that answer your question?
Yes, thank you.
You're welcome.
Hi, I also have a technical question. So all the cloud providers, they have all these great things that help to deal with things you were saying, like feature store or dealing with training service queue or data drift. I'm just wondering, is there a way to get around these products, make sure you're not locked into being dependent on these guys?
Yep, they're free. MLflow is free. Right? Evidently, AI is also free. It's open source. It's just that it requires a lot of time setting these environments up. Databricks, MLflow, they made it completely open source. So you can use that Delta Lake, which is the lakehouse architecture, is also open source now. Everything's free, basically. They're freemiums because they want you to get hooked on it, but at the same time, there are certain things, like the feature store for Databricks is not free, but there's other providers that give you feature stores for free. I bet this is going to be a
Anyway, that's
question.
only
Just watch
because I
this.
attended this talk that you gave at Pi Data.
Yeah,
do you like Python and data? Come to PyData last Wednesday of every month. But
Did you
do
just
have
make a pitch right now?
Yeah. But only
Are you
because
for
you
real?
asked me, Whit.
You're marketing your meetup group right now? Okay, you know what? Yeah, I will come.
Well, he actually gave a really good, he gave this talk, but even more technical at PyData. It was really
Yeah,
good.
don't tell them that I made no effort on this.
Well, I mean, everybody has their standard set of.
Well, this was targeted towards like business and technical. So
It's great. No, it's really good.
I wasn't looking for approval, but appreciate it.
Well,
I'm just messing with you, man. I'm just messing with you. I have a sense of humor. I'm sorry. Yeah.
Okay, so you talked about model explainability, but then you also said the cursed words deep learning. How do you get executives to agree to deep learning when you can't really?
I don't tell them that I use deep learning.
Okay, good. Nice.
They don't know. They don't know, and to be honest, they don't care. I mean, they would love if I dropped the words neural nets in there, because that's the hype, right? But man, I really posted on my LinkedIn. I said I won't use ChatGPT, but you can always ChatGPT it, right? Anyways, any other questions, guys? Was this talk helpful? Oh, there's one more. Okay.
I have a not so technical question. So going from like level 0, where like the team radar for data science is pretty much notebooks, when is a good time to start proposing to the business, say, hey, we need to put in MLOps, we have to start moving to up that level. So that's one part. And then like the other part is like, what in your opinion, is like the most critical piece or like an important piece when going from level 0 to level 1 that would set up like the journey for success?
Do you guys have a budget?
Hard,
Depends. Your answer depends. My answer depends on your answer now. So.
we could fight for one.
Oh, fine. So you don't have a budget. So, I mean, it's a very good question. And usually, so one of the things that I do is I parachute into pre-seed companies, startups in the US. This is one of the questions I kind of ask. So my job is to basically parachute in, set up their MLOps architecture, and then parachute out in the VC-backed companies. And this is the question that they ask is like, yeah, we're level 0, level 1. We don't have anything else. And so it depends on two things. One, if you're a startup, it's actually pretty easy to do because if you're a tech startup, you already have software engineers and stuff like that, right? So in that case, you're actually not at level 0, you're a little bit more. If you're a legacy company, right, or an enterprise level company, now you're in trouble. And the number one thing I say that you need is, get ready for this, executive sponsorship. If you don't have executive sponsorship, and there's a manager leading the initiative, you're going to fail. With a high probability, I can tell you that. It's because there are a lot of, how should I say this, difficult personalities at the C level that have different opinions. So if you work in a legacy environment, engineering, ops, commercial, right? And then you have ITIS. The problem with ITIS is that traditionally, it has not been a revenue maker for an organization. It's a cost center, right? They just build apps, they maintain whatever, blah, 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 blah. For the first time in the history of ITIS, AI has come along, which makes money for the organization. Everybody wants a piece of the pie, right? And the job is that the AI world has to be a Venn diagram where it shares, SMEs from the commercial and the operators and the engineer side. And then there's the ITIS who really understand this world, right? And to answer your question in a long-winded way, is you need to change the architecture if you're on a legacy enterprise level by getting executive sponsorship who will fight for you. If they don't, what happens is you get citizen data scientists. God, I hate that word, by the way. There's no such thing as rocket scientists. I don't know what citizen rocket scientists, but citizen data scientists exist. And they will do siloed versioning. And then the only time the commercial and operator people will understand that they need ITIS is when that person leaves. And they leave that R&D ML model that is making a lot of money for the organization, and they have no idea what to do. And that's when they come knocking on the door. So things have to fail before they ask for help. Okay?
Thank you.
Thank you for a wonderful talk, and I just want to know, like, what would the piece of advice you will give it to new internship, like, person. And like, when as a data scientist, when they go, like for my own example, I joined the company for internship program. In 4 months, develop one, prototype for them, and later they don't know what to do with that, right? So, how would you approach them later?
I'm asking for my consulting services. So what I would do is get two answers here. One is a data scientist. This is how I learned it. My background is in computer science, statistics, and economics. But data engineering is no such thing, right? Like there's no degree for that. If you really want your product as an intern, as a data scientist to see the light of day, learn how to do data engineering. Because when you need to productionize your model, you have to go to a data engineer to get that data and build the incremental. But if you can do it yourself and you pitch it to your manager, right? Guess what? I don't need any headcount, I'm going to need support. I just need access, right? Then you can build the whole darn thing and then show them the value. That's the learning curve that I've had to accept, is that when I did data science stuff and I was trying to productionize stuff, it was always, and data engineers are the unsung heroes of the data world. Everybody wants to be a data scientist, but data engineers are high value, high impact folks, right? And so if you can learn that world even just enough to be deadly, you leverage that and you go from there. Because then, end to end, if you're pitching the idea to a manager, it is no additional cost to them. And they're saying, oh, my existing team member here wants to scale up. Give them access. Does that answer your question?
Great presentation. It's very insightful. I learned a lot. So I just want to ask questions about the last several slides or about the dashboard.
Mm-hmm.
You don't have to go through those slides. I'm just
I like clicking this thing.
Okay. So in the last slide where there's anomaly detection and stuff, and then when people see that slide, they, there's an anomaly, so I better do something about it, right? But my question would be, what happens there's thousands of similar dashboards for different models? Obviously, we're going to automation for that part. So I'm just curious about your ideas about how we approach that automation. Yeah, thanks.
Very good question. I like it. There's another layer inside it that there's IP that I can't share, but I'll tell you what it is. It's a rank order. Okay? So what the algorithm does is it ranks based on impact. Right? Right after this is not the one that shows up when you drill down into it. There's something else that shows up before this, which is basically shows you the score of how bad this anomaly was. And then it gives you a number that tells you the impact from a dollar standpoint. Okay? Now the hard part is, there are two separate whys of the world, right, when you build something like this. One is an analyst who understands the asset. The other one are on-site technicians. Right? You got to convince them to do the work. So, to answer your question, when you do the rank order and you give them a number and you say, well, guess what? We're losing X amount of dollars on it, they put it on a high priority list and they action it. Right? And that is the IP that I sadly cannot share with you guys, but it simplifies the whole darn thing that says, oh, if you have 1,000 pieces of equipment, it doesn't matter. Here's the rank, action it this way. Does that answer your question? Try to extract IP out of it. Well, without that, enjoy the after party, guys. It was a pleasure.